Section 3.1, solve the system by addition. Here we are being asked to solve the system, a system of two linear equations, by the addition method. In the addition method, we're going to add these two together in a way that we eliminate one of the variables in order to find the solution or the point where these two lines intersect. My plan initially is going to be to let's eliminate the y. In order to eliminate the y, I don't want to have any y's. So what would you need to add to a positive 2 in order to get a 0? You would need a negative 2. So I want the first equation to have negative 2y, and I want the second equation to have a 2y, so that when I add those together I get 0 y's, and I've eliminated the y's. Okay, that's the plan. So in order to, the second equation has exactly what I want. In order to have a negative 2 in front of the y here, I need to multiply this first equation by 2. And when I do that, I multiply the entire equation to keep it balanced. So that will give me 2 times 10, 2 times 5 is 10x, minus 2y, 2 times that, equals negative 4. And then we recopy the second equation because we don't need to change it. We leave it the way it is. All right. Once we have opposites, additive numbers that add to 0 here in front of the y, we simply can add these two together. So let's do that at this time. Add the x's, we get 11x. Add the y's, we get 0. Add these numbers on the other side, and we get negative 11. Now we can find out what x is very easily by dividing both sides by 11. And so we've come up with x equals to negative 1. Now, when we're trying to get the solution, we're looking for the point. So we need more than just the x. So I'll pick either of the equations. I think I'll pick this one, x plus 2y equals negative 7. And I know that x is negative 1, so I substitute that in. Add 1 on both sides. Negative 7 plus 1 is negative 6. Divide both sides by 2. Negative 6 divided by 2 is negative 3. And so we come up with a point x as negative 1, y as negative 3. This is the solution. When we find one point where they intersect, we call this consistent. Okay, I'd like to do another example where something different happens now. Okay, in this next example, you'll notice that things aren't lined up. Before we work it, we need to look at the first one we did. We had the x's lined up and the y's and the numbers on the other side. We'll need that before we proceed to work this one. We need to get the y over there. So the first thing I'm going to do is take that first equation, subtract the 5y, so I get it on this side, subtract it off of there. So the first equation rewrites like this, and I'm going to leave the second equation exactly in the form that it's in. So this is my revised system. Now I need to think about what I want to eliminate. And you could eliminate x or y. It's really up to you. I think since we did y last time, I'll do x this time. So let's eliminate x. All right, we have a 4 in front of this one, and we go with a larger one. We have to get a number that the opposites are in front of the x. So the number that will work with negative 4 with positive 4 would be negative 4. So I want the first equation to have a negative 4x, and then the second equation will have a 4x, and that will add to give me 0 x's, which means I'll eliminate the x, and that's what I was planning to do. Okay, to get a negative 4 in front of the x here, and there are multiple ways you could do this. You could multiply the second equation by negative and leave that a positive, but I think it's easier just to be changing one equation. So I'm going to multiply the first equation by negative 2 in order to get a negative 4x, and the whole thing, negative times negative makes that positive 10y, negative times negative makes that positive 2, and recopy the second equation unchanged. All right, and now when we have opposites, we're ready to add these. So with the addition method, we add, and we get 0 x's, and we get 0 y's, so we get 0 over here. And on this side, I add 2 plus 0, and I get 2. And when I get something that is false, as we talked about earlier, that means there is no solution. In fact, those lines are parallel, they never cross, otherwise we would have a solution, right? And so we call this inconsistent. And probably no solution would probably be one of the choices on the test.